Hello students. Today we are going to discuss about the chapter called organic compound, which is from class 10 Icse, and this class will be completely based on the syllabus of 2024-2025. So let's start. So the topics to be discussed is organic compound and their representation, properties of carbon and hydrocarbon and their classification. Okay. Now let's discuss about organic compounds little bit. Key, what is organic compound? Basically, organic compounds are the compounds of carbon. Okay. What? The compound of carbon. Okay. Compound of carbon. That means for every organic compound, for every organic compound, carbon, the presence of carbon should be mandatory, or presence of carbon is necessary. Okay, so presence of carbon is necessary, understood? So the main component is carbon, but previously when there was no such thing, scientists just try to discover the things, that time it was considered the organic compounds are composed of some kind of natural theory, that is known as your vital force theory. What is vital force theory? Vital force theory means the force of nature. Okay, because of the force of nature, the compounds formed are known as organic compound, were known as organic compound. But later the research are developed and scientists proved that organic compounds can be made in laboratory also, can be made in laboratory also. So this is what organic compound. We are not going to go into such depth of the historical aspect of organic compound. We'll be talking about the representation of organic compound. As I told, the main component of organic compound is carbon. Now let's understand how to represent the organic compounds. So as we discussed, this part is completed. So now let's move on to the second part, that is a representation of an organic compound. देखो, organic compound can be represented in various forms, like first of all your molecular formula. Okay, molecular formula. So what is molecular formula? So listen, in molecular formula the basic and common thing is that you won't find any bonds here. You won't find any bonds here. Let's say one more example. Suppose C2H6. C2H6. There is no bond. Okay, there is no bond. It does not give any information about the bonds present in between the atoms. Okay, bond presents in between the atoms. Suppose let me write C2H5OH. C2H5OH. So there is nothing mentioned about the bonds. There is nothing mentioned about the bonds. Okay, second one is your Lewis structure or Lewis formula. So what is Lewis formula or Lewis structure? What is Lewis formula or Lewis structure? So Lewis formula means it just represent the lone pair of electrons. It just represent the lone pair of electrons. Let's say C2 C2H5 and OH. So it can be represented as, suppose C, okay, or CH2 means CH3, CH2 and OH. Okay, so this can be written as CH, H and H, again CH, H. Here you see the dots means the lone pair of electrons and H. That means the Lewis formula or Lewis structure represents the bonds as well as the lone pair of electrons. Bonds as well as the lone pair of electron. And third form of representation is your condensed formula. Okay, condensed formula, condensed molecular formula. Okay, so condensed molecular formula. Listen, condensed molecular formula, condensed molecular formula. Acha. In condensed molecular formula, it represents the connectivity. Connectivity of the atoms. Okay, connectivity of the atoms. Let's say, let me write C2H6. Okay, C2H6. So C2H6 can be written as CH3 CH3. So this is C2H6. Let me write, suppose C3H8. C3H8. So it can be written as C3, C2, C3. So you see 3 plus 3 to C8 and again C3. So C3H8. So this is your condensed molecular formula. So this condensed molecular formula represent the connectivity of the atoms. Now what is most important among all is the structural formula. Okay, the structural formula. So what is structural formula? Actually, structural formula represents all the bonds present in it. It means any compound, any organic compound. Let's say C3H8. So it can be written as C, H, again H. Here it's H, here it's H, and H. So now you can easily understand that the structural formula represents all the bonds, the condensed formula represents the connectivity of the atoms, the molecular formula represents no connectivity, just only formula, and the Lewis structure represents bond as well as the lone pair of electron present in it. Okay, so now this is what the representation of the organic compound. Okay, this is what the representation of the organic compound, that is also completed. Now as carbon is the main component of this organic compound, let us discuss about the properties of carbon. So now we'll discuss the properties of carbon. Okay, properties of carbon. Now let's understand what is carbon. It has atomic number 6. That means the electronic configuration will be 2 and 4. Okay, 2 and 4. That means the valency of carbon will be how much? 4. Valency of carbon will be 4. That means it will have 4 electrons can be connected to other elements or other atoms. Okay, it has 4 electrons that can be connected to other atoms. Okay, so as it has valency of 4, then this property of carbon is known as tetravalency. This valency of carbon is known as tetravalency. So what is tetravalency? Carbon has the tendency to form 4 bonds, as there are 4 electrons in its outermost shell, so it has the valency of 4, so it will form 4 bonds. That is what tetravalency is. So you can write, what is tetravalency? Now tetravalency is the tendency of carbon to make 4 bonds. Listen, these 4 bonds can be either with hydrogen. This is very common. When there is nothing, means it is connected to hydrogen. Because the valency of hydrogen is 1, so it will connect to hydrogen, carbon and hydrogen, and the other atoms. Okay, except hydrogen, what can be other atoms? Like oxygen, nitrogen and halogens. These are also known as heteroatoms. Okay, these are also known as heteroatoms. So carbon can either connected to hydrogen or oxygen or nitrogen or halogen, but at the end carbon will form 4 bonds. Okay, so this is what the tetravalency of carbon. Hope you understood. Now the next property of carbon is catenation. Okay, catenation. So what is catenation? Catenation means the self-linking property of carbon. Self-linking property of carbon means carbon can attach to a number of carbon atoms it want. Okay, so this is what self-linking property of carbon. So as It is the self-linking property of carbon, so it can form many carbon chains, right? It can form many carbon chains. First of all, can be a straight chain. It can be a straight chain, okay, straight chain. Second one can be branched chain, can be branched chain. Third one can be cyclic, can be cyclic, okay. So first of all, let us discuss about straight chain. So this is what straight chains looks like, because it is very straight. Not always when you see only the straight chain is only straight chain. Now you see C C C C C C, this also can be straight chain, because when you pull it up it will become straight, right? In generally, suppose you think this is a chain, this is some kind of chain or jewelry, so you just pull it straight, so it will become straight like this. So this is also a straight chain carbon compound. Now branch chain. So what is the meaning of branch chain? Branch chain means, suppose this is C C C C and C. Let's say one more C is attached here, one, but you see this is the longest, this is the longest chain, so this is the main chain, and this carbon atom is attached to it. So this is what the branched chain, okay. Now let's get back to cyclic chain. So what is cyclic chain? Suppose this is carbon, this is carbon, this is carbon, and this is carbon, okay. So this is what cyclic chain. So it can be like this also, C C C C. So this is also cyclic chain, okay. Understood? We have discussed many things. Let me discuss one more very important and simple thing. So you may need this, okay. So we'll be discussing about degree of carbon, degree of carbon, okay, degree of carbon. So what is degree of carbon? It is very basic. You have to find out, one carbon atom is attached to how many carbon atom directly, okay. Let's say carbon and carbon and carbon and carbon and carbon, okay. Okay, tell me about this carbon, how many carbons are directly attached to this carbon? Only this, for this carbon I am talking about, only this is attached, right? So that means the degree of this will be 1 degree carbon. This is what 1 degree carbon, because it is attached to only one carbon atom. And 1 degree carbon atom is also known as primary carbon, okay, primary carbon, okay. Second one, you see for this carbon it is okay, let it be. You see for this carbon, it is directly attached to this one and this one. That means how many carbon atoms it is attached to? 2 carbon atoms. So the degree will be, for this carbon the degree will be 2. This is called second degree carbon, or it is known as secondary carbon, okay. It is known as secondary carbon, okay. Now let's get back to this one. It is directly attached to 3 carbon atoms, so it will be considered as third degree carbon or tertiary carbon, okay, or tertiary carbon, okay. One more is there which can like C C C C and C. This carbon is attached to 1 2 3 4. That means the degree is 4 degree carbon, or it is known as quaternary carbon, okay. It is known as quaternary carbon. It is known as quaternary carbon. Hope you understood about the degree of this carbon. So what is the degree of this carbon? When a carbon atom is directly attached to one carbon atom, that is known as first degree carbon. When it is attached to 2 carbon atoms directly, is known as second degree carbon atom. When it is attached to 3 carbon atoms directly, it is known as third degree carbon. And when it is attached to 4 carbon directly, then it is known as quaternary carbon. Fine. Now let's move on to the next section. So the properties of carbon is completed. Next move on to hydrocarbon and their classification. So we'll be discussing hydrocarbon and classification. First of all, let us understand what is hydrocarbon is. Let's understand hydrocarbon, okay. Hydrocarbon, okay. So hydrocarbons are the compounds of hydrogen and carbon. Hydrocarbons are the compounds of hydrogen and carbon, okay. Hydrogen and carbon, Okay, compounds of hydrogen and carbon are known as hydrocarbon, or compounds of hydrogen, carbon, oxygen, nitrogen and halogens, those will be known as the derivatives of hydrocarbon. That means at the end those are also hydrocarbons. Okay, but strictly if you are following hydrocarbon, then it is the compound of hydrogen and carbon. Okay, compounds of hydrogen and carbon. Okay, now what shall we do? As we have defined the compounds of hydrocarbon, let's classify it. Okay, let's classify it. Hydrocarbons. Okay, hydrocarbons. Hydrocarbons can be classified into two types. Okay, two types. As I am going for the syllabus of ICSE only, that's why I am doing this classification. For higher classes, the classification is little different. So hydrocarbon can be classified into two types. One is your saturated hydrocarbon, saturated. Another one is your unsaturated, saturated and unsaturated. Okay, saturated and unsaturated hydrocarbon. Okay, saturated is what? When you find the presence of single bond between carbon and carbon. The presence of single bond between carbon and carbon is known as saturated hydrocarbon. And what is unsaturated hydrocarbon? When there is the presence of double bond or triple bond between the carbon atoms, that is what known as your unsaturated hydrocarbon. I hope you understood this. Actually, I am defining these things in a very simple manner, and only what is the thing needed for our exams. Okay, so these things are necessary, not that cyclic, alicyclic, aliphatic, those things are not necessary. Okay, so now we'll be discussing about saturated hydrocarbon, then unsaturated hydrocarbons. So saturated hydrocarbon, saturated hydrocarbon, saturated hydrocarbon. Okay, saturated hydrocarbon, as I have mentioned already, the presence of carbon and carbon single bond between two carbon atoms are known as saturated hydrocarbons. Okay, saturated hydrocarbons. Okay, to identify saturated carbon, it has a general formula, that is CnH2n plus 2. CnH2n plus 2. Acha, what is this N represents? This N represents for number of carbon atoms, and this N represents for number of hydrogen atoms. Okay, number of hydrogen atoms. So for saturated hydrocarbon, as I have mentioned, कि there is single bond between carbon and carbon. There is single bond between carbon and carbon. So the value of N can be taken as, means taken from N equal to 1. Okay, N equal to 1. Now let's put this value, C1H2 into 1 plus 2. C1H2 into 1 plus 2. So it will become CH4. It will become CH4. Now actually what is this compound? How to name it? Okay, now you see, H saturated hydrocarbon has a single bond between carbon and carbon. It is also known as alkanes. Acha, what is alk? Alk means number of carbon. N is the suffix for this hydrocarbon. Alk is the number of carbon, and ANE is the suffix for this single bond or saturated hydrocarbon. Right? Now let's write the values of N in this format or in this form of carbon. Okay, that is also known as your root name. So when N equal to 1, that means the number of carbon will become 1. So when N equal to 1, or when there is only one carbon, that word root will be meth. When there is 2, it will be eth. When there is 3, it will be prop. When there is 4, it will be but. When there is 5, it will be pent. When there is 6, it will be hex. When there is 7, it will be hept. When there is 8, it will be oct. When there is 9, it will be none. And when there is 10, it will be dec. it will be dead. But mostly for ICSE we need up to this much, it is enough. If you can remember up to this, it is better for you, right? So now let's name this compound. You see, for one carbon I have written meth. Okay, now let's write meth here. Okay, meth. Acha. H, it is a saturated hydrocarbon because it is defined from this formula or derived from this formula. Then for saturated hydrocarbon, what is the suffix ane? Then I can write methane. Yes or no? Yeah. So now let's put n equal to 2. If n equal to 2, so I can write C2H2 into 2 plus 2, that becomes C2H4 to C2H6, C2H6. Okay. Now you see the number of carbon here is 2. 2 means for 2, what is the word root or root name? Eth. So I can write eth. What is the suffix? Because you see it defines the formula, and when you, I'll show you, when you open it, like when you will write this in structural form, so it will become C hydrogen, 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 again hydrogen, hydrogen and hydrogen. You see, between carbon and carbon single bond is present, and 1 2 3 1 2 3 3 plus 3 6 CC2, so C2H6, so it is ethane. Okay, now from 3 onwards it's your part to write this compound of saturated hydrocarbon. Okay, understood? Now let's move on to next unsaturated hydrocarbon. Now unsaturated hydrocarbon, unsaturated hydrocarbon, exactly. So unsaturated hydrocarbon is classified into two parts. One is known as alkene, another is known as alkyne. You see here it's ane, here it's yne. Acha, what is the meaning of this ane? That means the presence of double bond in between the carbon atoms, and here the presence of triple bond between the carbon atom. If I define, it has a general formula like alkane, CnH2n, okay. So CnH2n, and it has the general formula CnH2n minus 2, Acha, now tell me, how many minimum bonds are present in this unsaturated hydrocarbon? Only 2. So we'll start for n equal to 2. Rest of these things are similar, like eth, prop, but, everything is similar. Now let's put for this one is C2H2 into 2. It will become C2H4. If I want to name this compound, what will be the compound? C2H4 means 2 means what? Eth. Let me write it. Okay. H. Dekho. Now we'll understand how it has got two bonds, means double bond in between carbon and carbon. Now let's do it here. Dekho, it is written as C2, so CC. Okay, then how many hydrogens are there? 4 hydrogen. Okay, 2 hydrogen for this carbon and 2 hydrogen for this carbon. You know, carbon has to satisfy the tetravalency. Now it has 2 bonds, 1 2 1 2. That means it needs 2 bond more, and there are no other atoms to connect. Okay, so in that case simply you will put 2 bonds. So 1 2 3 4, 1 2 3 4. You see double bond is present. As double bond is present, what is the suffix? ene. So I can write ethane. If it is prop, means C3H6. C3 means 3, 2 into 3, 6. C3H6, it will become your propene. Understood? Now let's write for this key C2H2 into 2 minus 2. So it will become C2H2. You see, 2 represents, again let me do the structural form of this. Okay, C only 2 H means 1 here, 1 here, 1 1 1 2 3 4. So this carbon also has the valency of 4, this carbon also has the valency of 4. Now this carbon is satisfied, this carbon satisfy tetravalency. If they are satisfied tetravalency, that means presence of 3 bond here in this particular case, then we can write for this C2 means what? Eth. C2 means eth, and what will be the suffix? YNE. What will be the suffix? YNE. Okay. So hope you understood this concept up to hydrocarbon and this classification. Next class will be doing the IPSC nomenclature along with the functional groups, substituents, everything. So till now you go through these things what I have taught, and also go through your books and you compare the things, try to understand it very well, because I have taught only the facts, nothing extra. Thank you so much.